Exercise 422. You guys get to look at baseball. I get to look at sales commissions in doing exercise 421. Here, we learn how to do the standard deviations, and I don't think we've done those before. And it really doesn't talk about standard deviations, I don't think, much in the book, but this is a formula and something that we will need to do throughout. Okay, we're going to do a lot of standard deviations, and so this is one of those that we'll build on a little bit. So really follow along on calculating standard deviations, and then it kind of becomes a habit. Actually, it becomes sort of easy, and it goes like this. So it gives us my commissions. Again, this is a data file, and so I download it. And in this case, it wouldn't matter what the order is. Okay, and for this exercise too, you have to look above because it says A, B, and C for all of them. It says determine the mean, median, and the standard deviation, and then I have to calculate two different coefficients of skewness. Yeah, so I've got my data, right? I put that in there, and then I just have to calculate the mean, and the mean is right just the average of those things. So I grab that and I just highlight those 15 values. And I hit the average thing up there in my auto sum deal, and there we go. So pretty simple. When we calculate, let's do the median then and get that done. And median, we have to go this route. I don't think it's over here. Let's take a look. Max, min, more functions I can hit, and that'll take me just right to the same thing as hitting this little FX there. Okay. And so statistical in order, oops, went a little far, median, okay, grab these numbers, highlight these numbers, and I get a 15.8 as my median, okay, which is that one right there, half of them below and half of them above. Okay. All we're doing when we calculate the standard deviation, right, is here's my mean, somewhere around 22, right? So really it's about here, okay? Okay, my median's down here, half above, half below, but my mean is somewhere right around here, okay? And what I want to do is calculate what the average distance is when I talk about standard deviation, what the average distance is of my commissions from the mean. And you can see I got some big ones. You know, there's a few here that are kind of gathered around, but then some of these other ones are quite a ways away from the mean. And so, you know, I'm guessing the numbers relative to these numbers, decent size. Okay, and the way to do that is simply this. Okay, I need to calculate how far each one of these is from the mean. Okay, and so I simply say this is equal to this one, okay, this particular commission minus my mean, and I want to hit my F4 key because that'll put my dollar signs there, and that'll keep my reference to this cell the same, and I hit enters, okay. And I could do it the other way, okay, it wouldn't matter, and the reason is if I did 21 minus 3.9, I'd have a positive 18. When I square them in this column, then it doesn't matter, right? It becomes a positive value, okay? Then I can just drag this down because I used that proper reference. There you go. So that's the difference of each of these from the mean, but we got positives and negatives and all those other things, and so we want to get rid of those, and the way we do that, we want to get rid of the positives and negatives, so the way we do that is square the answer. So again, to me the easy way to square it is just to say this is equal to this, hit my shift key in the 6 to the second power, hit 2, hit enter, and there we go. Because that reference is going to stay the same constantly to the cell to the left, I can just drag that down and I get goofed up answers. What did I do? Did I just not get far enough? Whoa, yeah, okay. So what I got to do is make my answer a little smaller. Now let's drag it down so I've only got 4 decimals. There we go. Sorry, I had too many decimals in there. And in fact, I could take it down even a little bit further. Okay, So now I've squared all those, it's made it positive numbers, and what I need to do then is I'm gonna do it this way, I guess, because I think that's how the book does it, even though I'm going to tell you I think the book may have done this one incorrectly. I'm going to sum those numbers. Okay. Whoa, I did something wrong. Oh, I hit average instead of sum. Screwed up all of my numbers. Okay, there we go. And then I'm going to, I've got the sum, and I am going to take the average of these numbers. But what the book did, and what I'll go ahead and do, there's actually two formulas for standard deviation, and I'll show you the Wikipedia version, although Wikipedia is not a great source. I think in this case we can kind of, well, it's not even the Wikipedia, it's the Bing version. Okay, how to find standard deviation. Okay, you calculate the mean of those squared differences, and that's called your variance, which I think we did variance. Maybe we did do standard deviation before, but then calculate the square root of the variance. This result is the standard deviation, but it says important note, if the data set is only a sample of the whole population, change the formula to divide by 1 less when calculating the variance. Excuse me. So hopefully I can start where I left off. So the correction, we would put in, so instead of using 15 to figure out your average, you'd use 15 minus 1 if you're going by what they call, Bessel's correction. Okay, and I believe that's how the book does it when they come up with their answer. And what the difference is that if you would call this a sample, then you should use the correction. If you call this a population, then you would not use the correction. Okay, and good call. I mean, to me, when I look at what question number 21 is, I would call that a population, but I think the book uses it as a sample. So we'll do it the book way, but I'll show you the other way as well, because oftentimes we'll do it the other way. So we've done that. So we do our average, and basically I made the formula probably more complicated than I need to. It's simply this divided by the number minus 1, right? Okay, and so I did it like this. This is equal to this. Okay, divided by, I'll need some parentheses here. Instead of doing 15, I make it more complicated. I come up here and I'll do the count. And again, this is sometimes oops. Okay, so I'll accept that correction, but now I got to go back and kind of finish this. Okay, minus, so I click in up here and I put in my, so it's C17 divided by the count minus 1. That should give me my average there. Okay, and it does. Okay, it's my average minus 1. So okay, and that comes out to 448. Okay, and that's, you kind of got to do that the long way. Would I have had to do the count thing? No, but again, if I had a larger data file, that would make more sense. Okay, now that is I guess sort of my variance, and so to calculate the standard deviation, it's to take the square root of that. Okay, so I need to take the square root of that to calculate my standard deviation, so it's just simply equal to this. Okay, and I got to use my little shift and my tint thing, and then I need a parentheses to the 1 divided by 2, and there we should have it. Okay, I got to pause again here. Okay, so we've calculated the standard deviation like they requested. Okay, now we got to look at the skew, and the book tells you that there's 2 ways to calculate skew. And one is called Pearson's method, which is this formula up here, and we call SK for skew is equal to 3 times the mean minus the median divided by the standard deviation, and that gives us Pearson. The other way they call it is the software method. Okay, there's actually a couple of ways to calculate that. There's the long way, which I probably won't show you, just because. Okay, I don't know if we do that later. And then there's the short way, which is just using the software, right? Okay, so we come up with different answers, which is kind of odd, but skew's not a precise thing. It just gives us an idea of whether it's positive or negative. If we have a positive number, okay, the further away it is from 1, the more skewed it is, or the further away it is from 0, the more skewed it is, either positive or negative. And if it's positive, it's skewed. I would call it means my hump is to the left, or the peak is to the left. If it's negatively skewed, it means the peak is to the right. Okay, but in any event, Pearson, so it's equal to, right? And I need parentheses, I think, because I'll do the top part here. 3 times, and I'm going to use another parentheses, the mean minus the median. Okay, end parentheses, and then I put another parentheses in there, and I divide that by my standard deviation. Okay, and so there's my Pearson's skew, and that one might even be available. I think it is actually in the software as well. We can take a quick look. Okay, and then there's the software version. Okay, over here I did the software version, and I'll just run through it really quick. We take our difference from the mean. So in this case, we take this negative number and we divide it by our standard deviation. Okay, and that gives us negatives and positives and all those other things as we cruise along here. And then we total those, I believe, yeah. Okay, we total all these, okay, and then we do a nice little formula that's equal to the number of these divided by 14 times 13. I don't remember where that comes from. I'd have to look at the formula itself. Again, really a lengthy process. Okay. On the other hand, we can come here and we can go hit that just so it empties it out. We come to stats. We look at skew. Okay. And we'll use the regular. Okay. We'll say OK. It asks us for the numbers. We identify those. We hit OK, and we're done. Okay. It did say, there was the one that said P, skew P. Let's just go take a quick look at that. See if that returns the same number that we have there. Nah, it doesn't. Okay, and so that's a little bit different. That might be a population or something versus. Okay, so in any event, we've got our skew, that's the software version, and the Pearson's version. So that should be it for 422.